Viewers, welcome back. Today we will start learning about Bitfields in C and union in C. So let's start. First of all, we are opening our application program, which is known as code block. The code block is already open. First of all, we have to create a new file. From this something that is very rememberable for understanding Bitfields. Bitfields is a type of a structure. Bitfields allow the packing of data in a structure that is especially useful when memory or data storage is at a premium. Typical example includes when a structure packing several objects into a machine word. For example, one bit flag can be complicated, and another one is reading flag formats. Non-standard file formats could be read in, for example, 9-bit integers. C allows us to do this in a structure definition by putting bit length after the variable. First of all, we see an example of a structure. Struct packed struct. This is our structure name. You are watching that structure name is declared with the keyword struct, so this is the struct keyword, and other one is structure name. Now in the body of structure we have to declare its member. Unsigned int f1 colon 1. We have to copy this line and again we type in this field. We are create a new variable f2, f3, f4. Sorry, we are not declaring f4, we are declaring a type another variable which name is type, and the size of type is 4. We are assigning the value of 4 is a bit field for this type. Unsigned int my underscore int colon 9 semicolon, and this is a structure variable, so we have to declare a structure variable struct packed struct pack. This is a variable name and this is a structure name. This is the structure name. We have to save this file with the extension .c. So here the packed structure contains five members. 3 members are 1 bit flag from F1 to F3 and a 4 bit flag which name is type, and another is 9 bit flag for another variable is my int. Now C automatically packs the other bit fields as completely as possible, provided that the maximum length of the field is less than or equal to the integer word length of the computer. If this is not the case, then some compilers may allow memory overlap for the field, while other would store the next field in the next word. So now we are describing the next section. Then the next section is union. So the union is another user defined data type. A user defined data type is a struct, another is union. So union is defined from the union keyword, union, 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 and union name, union name, and these are all the members of the union user defined data type. However, a special data type available in C that allows to store different data types in the same memory location. You can define a union with many members, but only one member can contain a value at any given time. Union provides an efficient way for using the same memory location for multiple purposes. To define a union, you must use the union statement in the same way as you did while defining a structure. The union statement defines a new data type with more one member for your program. The syntax is in front of you. Union and union name and member definitions are listed here. Member, definition, semicolon, dot it means one and more member definitions you can list here, and you can define the union member variables as same as structure way. Either you can define variable list here a comma b comma c, you can define union members here. Otherwise you can't, you do not want to declare the variable here. So you can declare the union variables by union keyword and union name with variable names separated by comma. So this is the syntax of union. The union type is optional and each member defined definition is normal variable definition such as int I, float f, or any other valid variable definition. At the end of the union's definition before the final semicolon, you can specify one or more union variables, but it is optional. So here is the same way that you will define a union type named data having 3 members. We can define a union name data, and the member definitions are, for example, int I, one member, float f, another member, sorry, semicolon, char str, another string of 20 characters. So this is a string array, and data is the variable name. Note that this variable name is capital and this union name is capital data, capital D small a t a, but the variable name is small d a t a. So C is sensitive, so these are different, but this is not necessary. You can define the same name as the union name as union variable name, but you can define data only for d variable. Now the variable of data type can be stored an integer and floating point number or string of characters. It means a single variable. It implies same application can be used for store multiple data types, multiple type of data. You can use any built-in or user-defined data type inside a union based on your requirement. The memory occupied by the union will be large enough to hold the largest memory for the member of union. For example, in this example, the data type will be occupy 20 bytes of the memory space, which can be occupied by the character string. So this memory can be shared both the members of the union data type. Now this is the question, how to access union members. So we are providing the way how to access union members. So first of all, to access any member of union, we use the member access operator, which is known as dot. The member access operator is coded as a period between the union variable name and the union member that we wish to access, which is same as the structure concept. You would also use the keyword union to define the variables of union type. So let's take an example. which describe you the complete description of the union working. So first of all we define a main. Structure union is also created, and a variable is declared in the main. So this is the private variable for it. Union theta d dot I equal to 10. So this is the assignment for union members. D dot F equal to 220.5.5. Now the third member is str copy cpy d dot str comma C programming semicolon. Now three numbers that we are declaring in union, and this is the fifth way for compile time initialization of union members. Now we can print these members value. Now we can use printf data dot I colon %d for integer variable slash n comma d dot I. Now we have to copy this line for easy printing. Data dot f colon %f for float variable. The second member is float, so d dot f. Now third member data dot str colon %s. So d dot str. Now both of three are printed here. Control F9. What is the error? So this is the error. We are not declaring any header file, so this is the error. Hash include stdio.h hash include string.h. Now this is in working position. Now you can see when this code is compiled and the result is executed, it produces the following result that is in front of you. Here we can see that the value of I and F members of union got corrupted because the final value is assigned into the variable that has occupied the memory location, and this is the reason that the value of str member is getting printed very well. Now let's look into the same example once again. If we printed or access the value is 1 by 1, so what is the way for 1 by 1 accessing? 1 by accessing, we have to cut this line from here, and after the assigning the value we have to print. Now second line, cut and assigning second value, then print. Assign third value, then print. So now the final result is in front of you. Now here all the members are getting printed very well because the one member is being used at a time. So memory are shared among the union variables. So memory is shared, so we can use this same memory by every union members at a time, but we can't use this memory at the same time for each members. So this is the use of union. Press enter. Would you like my episodes? Please share and subscribe and comment my videos. See you in the next videos. Till then, keep learning and goodbye.